In 1787, a student astonished a math teacher by quickly solving the problem of finding the sum of integers from 1 to 100. That intelligent student was Carl Friedrich Gauss, who later became one of the greatest mathematicians of all time. In this video, we will learn how Gauss solved the above problem. First, let's consider a simpler problem than Gauss's problem, which is to calculate the sum s of integers from 1 to 10. The method here is to group two numbers into a pair, such that the sum of each pair has a constant value. Here, we group number 1 and number 10 together. The sum of these two numbers is 11. Next will be number 2 and number 9. The sum of these two numbers is also 11. Then, number 3 and number 8. Number 4 and number 7. And finally, number 5 and number 6. An interesting thing here is that each pair of numbers has a value of 11. So the sum s can be rewritten as follows. That is equal to 5 multiplied by 11. The number 5 here represents the number of pairs. Since we have 10 numbers, we will group them into 5 pairs. And 11 is the value of each pair. Therefore, the sum s is equal to 55. Returning to the problem of Gauss, which is to calculate the sum s of integers from 1 to 100. Continuing to apply the method of pairing two numbers such that their sum has a constant value. Group number 1 and number 100 together. The sum of these two numbers is 101. Next will be number 2 and number 99. The sum of these two numbers is also 101. Then, number 3 and number 98. Number 4 and number 97. And similarly, we pair the remaining numbers. Finally, numbers 50 and 51 are grouped together. Each pair of numbers has a value of 101, so the sum s now will be that is equal to 50 multiplied by 101. The number 50 here represents the number of pairs. Since we have 100 numbers, we will group them into 50 pairs. And 101 is the value of each pair. Therefore, the sum s is equal to 5050. To generalize the problem, let s be the sum of all integers from 1 to n. Continuing to apply the method of pairing two numbers into one group, the value of the expression s now becomes The initial expression S has n terms. After grouping the numbers into pairs, the number of terms is now n over 2. Now, S equal to n over 2 multiplied by n plus 1. The number n over 2 here represents the number of pairs. With n numbers, we will group them into n over 2 pairs. And n plus 1 is the value of each pair. Therefore, the sum S is equal to n multiplied by n plus 1 divided by 2.